Okay, this is section 8.6 over indirect measurement. So what we're going to do on this section is look at pictures, or you're going to have to draw your own picture to set up a proportion to solve for a missing side length. So on the first example, it says find the value of x. So we have two triangles. We have the smaller triangle inside the larger triangle. Here's our larger triangle. When you set up the proportion, try to be consistent about it, and if you're going to start with a big side, then make sure you start with a big side on your second ratio. So when I set mine up, I'm going to do big ratio, big over small when I do my ratio. So I'm going to choose a side length on the big triangle. So I'm going to choose 22 first. So 22 will go over the small triangle, and make sure you use the side that corresponds with 22. So if I use 22, then I have to use 10 for my small triangle. So my first ratio is 22 over 10 equals, now I go to the other big side, and that would be our x over the smaller triangle, which is 5. So I've set up the proportion. Now I can solve for x, the missing side of the bigger triangle. So remember, we just cross multiply. So we have 10 times x, that's 10x, equals 22 times 5. So we have 10x equals, and 22 times 5 is 110. We divide both sides by 10, cancels here, so x equals 11. So that means that on our larger triangle, x equals 11. Okay, example 2, we're also looking for x, which is on the larger triangle. We still have a smaller triangle within the larger, so here's the smaller triangle within the larger. Okay, so the blue triangle is our smaller triangle, the orange is our larger triangle. So I'm going to, again, like last time, I'm going to go big to small when I set up my proportion. So I'm going to choose x first. So if I choose x and put it over the small side, these are my corresponding sides. So on the bottom of my ratio, it should be 8. Equals, I'm going to choose 6 for the next big side, and it corresponds with 3, so my second ratio will be 6 over 3. Now I can cross multiply. So I have 3x equals 6 times 8, which is 48, divide by 3, and 48 divided by 3 is 16. So x equals 16, the missing side of the largest triangle. Okay, now I have example 3, and there's pictures this time. We have a tree that makes up the small triangle. So there's a small triangle here. We have the height of the tree, and then it's probably the shadow of the tree, that's 24. And then we have the larger triangle that represents the height of a building and its shadow, which is 56. We are looking for the height of the building. So when we set this up, I'm going to keep going using big to small, and I'll start with the height of the building. So I'll say x over, and its corresponding side is the 21, the height of the tree. So height of the building is x over height of the tree, which is 21, equals, now I'm going to do the shadows. So big triangle, which is 56, over 24, my smaller triangle here. Now I can cross multiply and divide. So I have 24 times x equals 21 times 56. So 21 times 56 is 1,176. I'll divide both sides by 24, and x is 49. So that means the height of this building is 49 meters. And that's your answer. Okay, on the last three, we had actual pictures. On these next three, 4, 5, and 6, on these examples, there's going to be word problems. So I'm going to read the word problem and locate the important information to set up my proportion. And I'm going to draw a picture, because if you're a visual learner, a picture will help you set up your proportion. So when Stephanie stands 2 feet from a lamppost, her shadow is 3 feet long. So that's what I'm going to use for my first ratio, 2/3. Now, I'm going to put the words in front to help me set up my second ratio. So she's 2 feet from lamppost. So I'm just going to put from post. And this is her shadow. So that's how I'm going to set up my proportion. So she's 2 feet from a lamppost and her shadow is 3 feet. If Stephanie is 5 feet tall, how tall is the lamppost? Okay, I'm going to draw a picture. So Stephanie, here's Stephanie. She stands 2 feet from a lamppost. So here's our lamppost. This is 2 feet. Her shadow is 3 feet long. So I'm going to put it past the lamppost, 3 feet. She is 5 feet tall. How tall is the lamppost? So I'm going to put X here. If I make this into 2 triangles, like we did last time with the picture given, here's my small triangle, and here is my large triangle. Now, when you set up the proportion, let's continue with big to small. So actually, I'm going to scratch this. Just look at the picture. Let's do big to small, just like we did before. So I'm going to start with the big triangle, and I'll start with X. So this is X over, and it corresponds with Stephanie's height, which is 5, equals, now the big triangle is this whole length down here. So I need the total. 3 plus 2 adds up to 5. So I need to make sure I put 5 and not just 3 or 2. So 5 over the smaller triangle, which is just 3. So I have the height of the lamppost over the height of Stephanie equals the total shadow over just Stephanie's shadow. So now from here I just cross multiply and divide. So I have 3x equals 5 times 5, and 5 times 5 is 25. Divide this by 3, and x equals 8.3 repeating. And this is in feet. So that means that the height of the lamppost is 8.3 feet. Okay, example 5. Again, I'm going to draw a picture first because that's what helps me. So Charlie walks away from a tree along its shadow until his head is in line with the top of the tree's shadow. So first, I'm going to draw a tree. Here's my tree. And it says Charlie walks away from the tree. So here's Charlie. And it says Charlie is standing 15 feet from the base of the tree. So this length right here is 15 feet. And he's 6 feet from the end of the shadow. So going past Charlie is 6 feet. Charlie is 5 feet tall. What is the height of the tree? So I'm going to put X here because I don't know. So my two triangles, I've got a small triangle here, and I've got the larger triangle that makes up the tree here. So again, I'm going to do big to small. So I'm going to use X first. That's on my bigger triangle, the height of the tree, over its corresponding side, which is the height of Charlie, so 5, equals the big triangle, the whole length of the shadow. So this whole length down here, 6 plus 15, and that total length is 21. So I need to put 21 on top, and its corresponding side is just this piece right here, the shadow past Charlie, which is 6. So now I can cross multiply and divide, and I'll be able to find the height of the tree. So 21 times 5 here, 6x equals 105, divide by 6, and x equals 17.5. So that means the height of this tree is 17.5 feet. Okay, this is the last one. So this says we have a mirror on the ground. So I'm going to put a little mirror just laying on the ground. And it's 8 feet from Ricky. So I'm going to put, this is 8 feet, and then here's Ricky. Ricky can see the top of the pole in the mirror of the flagpole. Oh, I missed a part. It says a mirror is on the ground 8 feet from Ricky and 19 feet from a flagpole. So this is going to be 19 feet, and here's the flagpole. Ricky can see the top of the pole in the mirror. If Ricky is 6 feet tall, so this is 6 feet, his height, how tall is the flagpole? So I'm going to use X. If I make my two triangles, here they are. I've got my large triangle with the flagpole, small triangle with Ricky. So I need to find the height of the flagpole. So I'm going to continue using big to small. If I use the height of the flagpole first, I'm going to say X over, now the small height is Ricky's height, which is 6, equals the length from the flagpole to the mirror, which is 19 feet, over the length from Ricky to the mirror, which is 8. So now I can cross multiply and divide. So 8x equals 6 times 19, which is 114. Divide by 8. X equals 14.25. So that means the flagpole is 14.25 feet tall. There we go.